I love The Lord of the Rings. I fell in love with the books long before they were made into movies. Sure, there are some problems with Tolkien, especially when viewed through modern lenses, but he masterfully crafted a uniquely British mythology that will last generations. Early in the first book, there's an especially poignant moment when the faithful Samwise Gamgee pauses just a moment as he and Frodo are embarking on their journey, saying, "This is it. If I take one more step, it'll be the farthest from home I've ever been." Such a simple statement, but somehow it encapsulates the entire spirit of adventure, that first step into the unknown. Part of what makes it so powerful is that even though none of us has ever been to the Shire, Tolkien masterfully describes it for us in enough detail that we feel we know every tree and every field and every person. We feel at home there. It's familiar, it's comfortable. One more step. That's how adventures begin. I feel that those who are attracted to science are at heart adventurers. Scientific training is rigorous and, though seldom as dangerous, research is often as fraught with difficulty and setbacks as many, if not more, than those encountered by the Fellowship of the Ring. And yet, as much as we enter into science because we want to take that one next step, to see something no one has seen before, to unlock a secret of the world no one knew, to do something extraordinary, an undergraduate education in science often becomes so mired in learning science facts, learning settled science, that we lose that sense of adventure and wonder and excitement. In a real sense, though, our undergraduate education is like Tolkien describing the Shire, painting the intellectual landscape we're stepping into in enough detail that we not only know which direction we want to take, but also we'll know when we're taking that one more step into the unknown. The trouble is that the training lasts so long that many drop out of careers in science because that spark of adventure that attracted them to the field in the first place was never kindled into full flame. Indeed, they begin to doubt that adventure in science even exists. This is especially tragic because research really is a form of adventure, but it's an adventure of single steps. The only way to show this is through examples. For instance, here's one of my favorite studies, published in 2006. Cues of being watched enhance cooperation in a real-world setting. I love this study, not because it is especially groundbreaking, but because it is both remarkably simple and remarkably clever. To understand why, let's enter into its intellectual landscape. It starts with a simple statement of fact. People tend to be generous even to people they don't know. It doesn't always seem that way, especially in these difficult times, but it's nevertheless true. Especially compared to most other organisms, humans are remarkably cooperative. While this is encouraging to hear, it's been notoriously difficult to account for from an evolutionary perspective. In the simplest formulations of natural selection, we shouldn't cooperate with other people at all. We should take whatever advantages we can to ensure our own survival and reproduction, and we should assume everyone else will too. But humans and many other organisms, in fact, don't behave this way at all. And so the scientific community has had to come up with more sophisticated understandings of how natural selection works. One explanation that the authors of this paper refer to is the idea of reciprocal altruism. This is basically the old maxim, "I'll scratch your back if you scratch mine." Intuitively, this makes a lot of sense. I should be willing to do something for you at a cost to myself if I can expect that you'll return the favor. But why should I expect that you'll return the favor in the first place? From a classic understanding of evolutionary theory, I would be a fool to take you at your word. What's to keep you from taking whatever resources I give you, using them to your advantage, and then never returning the favor? Well, one explanation is that individuals living in social groups have multiple chances to exchange resources. Those individuals also have memories of past interactions. In other words, if you cheat me this time, I'll remember that and I won't help you out the next time. And humans find it even harder to cheat than most other organisms because we can communicate so effectively. If you cheat me, not only won't I help you in the future, I'll warn everyone else about your behavior too. This leads to the idea of reputation management as a tool for ensuring cooperation in social groups. If I know I'm being watched, I should behave myself. Otherwise, word might get out that I'm not to be trusted, and if that happens, people might not be willing to help me out when I need extra resources. The mere possibility of getting those extra resources in difficult times is such an advantage that I should be doubly careful. Not only should I behave when I know I'm being watched, I should behave even when I think someone might be watching me, even when I think there's a chance that somebody might be watching me. So that's the theory the authors are working with in this paper. That's the broad description of the Shire, if you will. But the authors zoom in for a closer look. One thing that's really cool about this theory is that it's actually been tested in the laboratory. The authors only discuss a couple of these tests, but that's all you really need to get the picture. In these tests, subjects have been asked to participate in games where they have the choice of giving money to others or not. Often in these games, they also have the choice of how much money to give to others. Critically, they don't know the other players, and there's no real-world consequence if they choose to keep the money for themselves. Rationally, then, you'd expect subjects would keep as much money as possible for themselves, and often they do. However, when researchers include even subtle clues that the subject is being watched, and we're talking really subtle here, such as a faint pair of eyes on the screen, or in some experiments, 3 dots arranged in an inverted pyramid suggesting 2 eyes and a nose, subjects are less likely to behave selfishly, and they tend to give more generously. That's kind of mind-boggling. Nothing at all has changed, except something that subconsciously reminds subjects of eyes watching them. But that's all it takes to get humans to cooperate. We seem to give more than we have to in order to protect even the slightest chance our reputations might be harmed. At this point in the literature review, we've reached that point in The Lord of the Rings where Samwise Gamgee makes that poignant remark. So, what is that one more step that will take the researchers into unknown territory in this research paper? In this case, it's the fact that every test up to this point of the reputation management theory has been done in the laboratory. No one has checked to see if this idea holds up in the real world. That's the step further. That's the unknown the authors are stepping into. Granted, that might not be an adventure on the same scale as taking the Ring of Power into Mordor, but it's an adventure into the unknown nevertheless. The authors have no idea what the outcome of the experiment might be, just as Frodo and Samwise have no idea what awaits them. And the scientific community has no idea what their findings will mean to our understanding of cooperative behavior, much as the readers of The Lord of the Rings can't possibly guess the twists and turns as that story unfolds. And that's really the intuition you have to develop as you're reading the scientific literature. Every study takes the scientific community one step further than it's ever gone before, and it takes that step in a definitive direction. Just think about how specific this study is. It's not dealing with the entire evolution of human cooperation. It's not dealing with all theories about how that came about or what sustains it. Rather, it uses as its starting point some findings from laboratory experiments that confirm one theory of human cooperation and modestly extends them to a real-world setting. That's the level of specificity you should be aiming for in your own literature reviews. Your unknown can't be so broad as finding the cure for cancer. or even finding the cure for some particular cancer. That would be the end of the journey, not the start, and it's the start of the journey, that one small step that your literature review brings us to. This presents something of a paradox, though. How in the world, in a 1 credit hour course, in one semester, are you supposed to become expert enough to know what the scientific world doesn't know? How are you supposed to know what makes a good question, a question worth asking, a question that can be answered in a single research study? Simply put, you aren't going to become expert enough, though you're going to be surprised at how expert you actually do become through this project. Importantly, though, you don't have to be an expert. Most of the hard work has already been done for you, hiding in plain sight. The trick is knowing where to look. As we've been discussing, introductions tell us how the journey begins, that single step into the unknown. You should get into the habit of reading introductions, not just for the information they contain, though that's important, but also for how they're structured, for how authors of these studies propel their audiences forward. Each introduction can serve as a model for your own literature review. However, each introduction is asking questions that the rest of the paper hopefully answers. As such, literature reviews are a lousy place to look for new questions, for new steps forward. For that information, you need to look in the discussions. Each discussion explains how the authors interpret what the data they generated in their study means. They almost always start with narrow interpretations related to the specific research questions developed in the paper's introduction. However, they usually move to broader interpretations related to larger research questions. Additionally, they often discuss strengths and weaknesses of the present study, as well as some call for future work that needs to be done in order to understand the world more completely. Here, we can leave the fictional world of Tolkien behind and draw inspiration from the real-world explorers Lewis and Clark. As most of you know, these intrepid adventurers set out with a large crew to map out the land acquired by the United States in the Louisiana Purchase and to find a passage to the Pacific Ocean. The journey in all lasted 3 years. Now, Lewis and Clark didn't cover every inch of the Louisiana Purchase, nor did they learn about everything of potential interest to the folks back home. They did, however, draw upwards of 140 maps along the way, highlighting features such as the Continental Divide, Yellowstone, and abundant natural resources. They also chronicled their encounters with the indigenous people they met along the way. They also brought back with them countless plant and animal specimens, many of which Americans had never seen before. Think of everything they brought back, from travel logs to biological samples to maps to drawings of strange creatures and unfamiliar landscapes. That was all data, findings that could be used to inform future expeditions. And that's really what discussion sections of scientific papers do. In addition to providing interpretations of the existing study, they also suggest starting points for future study. Returning to the study on human cooperation, the authors found that putting up inconspicuous pictures of human eyes in a room made people more likely to contribute, and to contribute significantly more, to an honesty box, a collection box used by office workers to contribute to beverages for the workplace. That finding provided strong support for the reputation management hypothesis. However, it was far from the end of the story. Rather, it suggested new starting points for new studies. And it's easy to see how, if we go in and just highlight any words or phrases that suggest uncertainty. For instance, the authors say they don't believe that the pictures of eyes simply drew better attention to the notice that office workers should pay for their drinks. Believe isn't know, and the language suggests that a future study could explore this possibility. In the next paragraph, the authors say they believe images of eyes induce a feeling in participants that they're being watched. Again, believe. It suggests uncertainty. A future study might test to see if subjects really do feel like they're being watched. Most interestingly, the authors suggest that if subtle cues of being watched can affect how people behave, then it calls into question a huge body of research that relies on economic gameplay. They don't state this as a fact because they simply don't know. Instead, they use language like, "it is quite possible," and "may be sufficient." Learning to look for the uncertainty expressed in the discussion sections of primary journal articles will greatly simplify your work in trying to identify a specific gap in understanding, a gap that could be addressed in a single research study set up by your own literature review. So, don't try to invent the wheel with your capstone projects this semester. Rather, take advantage of the work that true experts in the field have done for you so you can narrow down your topics. No, identifying a gap in scientific understanding isn't easy. However, it's not as hard as you've probably made it out to be. As always, then, be gentle with yourselves and kind to one another. Thanks for watching.